The only place where you find nickel without iron is in alloys that are produced for industrial purposes here on Earth. We have a visitor from the cosmic street to our backyard. It may not be a rock.
There are some things in the universe that simply should not exist, and we just found one. An object from deep space, 3I/ATLAS, is tumbling through our solar system, and it's made of a material that has scientists questioning everything they know about physics. Forget what you've learned about comets being dirty snowballs. This thing is metallic, but an impossible kind of metallic. It's a cosmic paradox that points to one of two mind-blowing possibilities. Either the universe is home to natural phenomena far stranger than we've ever dreamed, or this object wasn't made by nature at all. What's streaking through our cosmic backyard is about to change the world. Echoes from a distant star. You see, space is mostly empty. That's a fact we take for granted. For every star, for every planet, there are trillions upon trillions of miles of absolutely nothing. So, when something comes visiting from another star system, it's a big deal. It's like a single ship from a lost continent washing up on our shores. We've only ever confirmed 3 of these visitors. The first was Oumuamua, a cigar-shaped enigma that tumbled past us in 2017. The second was Borisov, a more familiar-looking comet. But the third, detected on July 1st, 2025, is the one that has truly shaken the foundations of science. Its name is 3I/ATLAS, and it's the messenger we never expected. The discovery was made by the Atlas survey team in Chile, a group of dedicated sky watchers whose job is to scan the heavens for asteroids that might pose a threat to Earth. On that fateful night, their systems flagged an object moving at a blistering 130,000 miles per hour. That's fast enough to travel from Los Angeles to New York in just over 1 minute. Immediately, they knew this was no ordinary space rock. Its speed was far too great for it to be gravitationally bound to our sun. This thing was a traveler, a true interstellar wanderer. Astronomers around the world scrambled, pointing every telescope they could at the fleeting visitor, and the first piece of data they got back was its path. The thing nobody tells you about objects in space is that their paths are dictated by gravity, like a train on a track. They follow predictable curves called orbits. 3I/ATLAS had what's known as a hyperbolic orbit with an eccentricity of 6.141. In simple terms, that means its path is so extreme, so open-ended, that it's going to swing around our sun once and then get flung back out into the void, never to return. It's a one-way trip. But here's where things get weird. Harvard astrophysicist Avi Loeb, a man who's not afraid to challenge the mainstream, ran the numbers. He calculated the odds of a random object from deep space passing so closely to Venus, Mars, and Jupiter on its journey through our system. The number he came up with was staggering, a 0.005% chance. That's like throwing a dart from space and hitting a specific dime on the ground. To Loeb and a growing number of others, this didn't look random. It looked intentional. It looked like a probe on a carefully planned survey mission. Many people are crazy about this idea, dismissing it instantly. But the strangeness was only just beginning. The real shock came when they looked at what 3I/ATLAS was made of, as the Very Large Telescope, or VLT, in Chile locked onto the object. It split its light into a rainbow of colors, a spectrum. This spectrum is like a chemical barcode. Every element, every molecule, absorbs and emits light at specific frequencies, leaving unique lines on the spectrum. It's how we know what stars are made of from millions of light years away. When the team analyzed the barcode of 3I/ATLAS, they had to check their instruments. They thought something was broken. The spectrum showed a massive screaming signal for the element nickel, but the signal for iron, which is almost always found with nickel, was practically non-existent. It was like finding a forest with leaves but no trees. A pure nickel-rich object of this size, with no iron to go with it. That's not a comet. That's not an asteroid. That's a metallic alloy humanity has never seen before in nature. The messenger had arrived, but its message was written in an impossible language. What could create such a thing? The universe had just thrown us its greatest puzzle yet: the unnatural signature. To understand just how earth-shattering the discovery of iron-poor nickel is, we need to talk about how the universe builds things. You see, the cosmos is like a giant factory. The furnaces of this factory are the cores of stars. Through nuclear fusion, stars smash lighter elements together to create heavier ones. Hydrogen becomes helium, helium becomes carbon, and so on, all the way up the periodic table. When massive stars reach the end of their lives, they explode in a spectacular event called a supernova. This explosion is so violent that it forges the heaviest elements in the universe, including nickel and iron. The key thing is, the physics of this process dictates that nickel and iron are created together. They are cosmic brothers, forged in the same stellar fire. Finding a massive chunk of nickel without a corresponding amount of iron is like finding a human who was born without a skeleton. It violates the fundamental rules of cosmic creation as we know them. On Earth, we can separate these metals through industrial processes, smelting and refining them to get pure forms. But in space, nature doesn't do that. Asteroids, the leftover building blocks of planets, are a perfect example. The metallic ones are almost always a mix of iron and nickel. In fact, for every pound of nickel you find in a typical meteorite, you'll find about 10 to 20 pounds of iron. 3I/ATLAS has flipped that recipe on its head. So the question becomes, if a star didn't make it this way, what did? Scientists scrambling for an answer turn to the most extreme events the universe has to offer. One idea is a kilonova. This is what happens when two neutron stars, the ultra-dense collapsed cores of dead stars, spiral into each other and merge. The collision is so catastrophic that it rips apart the very fabric of space-time, creating gravitational waves. The energy released can, for a brief moment, outshine entire galaxies. The conditions inside a kilonova are a chaotic soup of exotic physics. And some models suggest that it might be possible for such an event to spew out debris with weird elemental ratios, creating pockets of matter rich in heavy elements like nickel, while being poor in others like iron. It's a plausible, yet incredibly rare scenario. We've only just started detecting kilonovas in the last decade. Another possibility is an asymmetric supernova. We tend to think of supernovas as perfect, spherical explosions. But what if they're messy? What if a star collapses unevenly? Some theories propose that these lopsided explosions could act like a cosmic centrifuge, blasting out different elements in different directions. You might get jets of pure nickel shot out from the star's poles, while the heavier iron remains trapped in the collapsing core. If 3I/ATLAS is a piece of shrapnel from such an event, it would be a breathtakingly rare specimen, a perfectly aimed bullet, fired across interstellar space for millions of years. But then, the James Webb Space Telescope delivered the second gut punch. Its powerful infrared eyes examined the faint cloud of gas, or coma, surrounding the object. In comets from our solar system, this coma is mostly water vapor sublimating off the icy nucleus as it gets closer to the sun. But 3I/ATLAS was different. The data revealed an unprecedented carbon dioxide to water ratio of 8:1. This is the highest ratio ever recorded for any comet, by a huge margin. Not only was the object's core made of an impossible metal, but its icy shell was also unlike anything in our cosmic neighborhood. This is where Avi Loeb's theory starts to sound less like science fiction and more like a terrifying possibility. The thing nobody tells you is that when you have two completely independent anomalies in the same object, an impossible trajectory and an impossible composition, scientists start to get nervous. Coincidences are rare in physics. Loeb argues that this unique chemical fingerprint, this double anomaly, could be a sign of manufacturing. It's a fingerprint that doesn't match anything we know. He suggests this could be an engineered probe, a piece of alien technology deliberately sent to our system. The nickel-rich alloy could be a superior building material, and the carbon dioxide could be exhaust from a propulsion system. Suddenly, 3I/ATLAS wasn't just a rock. It was a potential artifact from another civilization who made 3I/ATLAS. The idea of an alien probe is, for most people, a wild leap. But let's walk through the logic because it's less crazy than it sounds. Many people are quick to dismiss the notion, but the evidence is compelling when you line it up. You have an object on a trajectory so precise, it's statistically almost impossible. You have a core made of a metallic alloy that defies the known laws of natural cosmic formation. You have a gaseous halo that has a chemical composition unlike any of the thousands of comets we've ever studied. At what point do you stop looking for convoluted natural explanations and start considering the possibility that the simplest answer is the correct one? It was made? Let's reconsider Oumuamua for a second. It was our first interstellar guest. It was shaped like a cigar or a pancake, something we'd never seen. And most importantly, as it moved away from the sun, it accelerated. It sped up, pushed by a mysterious force that wasn't gravity and wasn't the typical outgassing you see from a comet. Avi Loeb famously proposed that Oumuamua was a light sail, a thin sheet of material pushed by the sun's radiation, a technology we ourselves are trying to develop for interstellar travel. He was largely dismissed by the scientific community, but now, with 3I/ATLAS, his ideas are getting a second look. It feels like lightning has struck twice in the same place. So if we entertain the idea that 3I/ATLAS is an artifact, what could it be? Its 130,000 miles per hour speed is incredible, but for interstellar travel, it's actually quite slow. This suggests it's not a ship carrying passengers. It's more likely a probe, an uncrewed scout sent to gather information. Think of our own Voyager probes, which are now drifting in interstellar space. In a million years, they could drift into another star system carrying their golden records. 3I/ATLAS could be the alien equivalent. Its seemingly deliberate flyby of Venus, Mars, and Jupiter could be part of a mission to scan for planets with the potential for life. The materials themselves offer more clues. Why use a pure nickel alloy? On Earth, we add nickel to steel to create stainless steel, which is incredibly resistant to corrosion and high temperatures. An interstellar probe would have to travel for millions, maybe billions of years through the harsh environment of deep space. It would be bombarded with cosmic rays and micrometeoroids. It would need to be durable beyond anything we can currently engineer. A dense, iron-poor nickel alloy might be the perfect material for such a journey, a kind of alien armor. The thing nobody tells you is that the materials an advanced civilization would use would likely look like magic to us. And this alloy is certainly pushing the boundaries of our understanding. Then there's the most mind-bending idea of all, something the brilliant and controversial Avi Loeb has called isotopic encoding. You need to get ready for this because it sounds like something straight out of science fiction. What if the message from an alien civilization isn't a radio signal or a drawing? What if the message isn't what the probe does, but what it is? To get what this means, you have to think about the very building blocks of the universe. Atoms. Let's take an element like nickel. You might think all nickel atoms are the same, but they're not. There are different versions or isotopes of every element. Think of it like this. They're all still nickel, but some are like the standard model, while others have a few extra parts called neutrons in their center. On Earth, and everywhere else in the universe we've looked, these different isotopes exist in very specific, predictable amounts. Nature has a recipe, and it almost never changes. Here's where the idea gets wild. An advanced civilization wouldn't have to follow nature's recipe. They could, in theory, build an object atom by atom, choosing exactly which isotope to use for each piece. They could create a metallic alloy with an isotopic ratio that is completely unnatural. It would be like finding a beach where exactly half the grains of sand are black and half are white, arranged in a perfect checkerboard pattern. You'd know instantly that it wasn't the work of the wind or the waves. This is the core of isotopic encoding. The probe itself could be a vast library of information embedded into its very atoms. It would be like an atomic QR code. A normal QR code uses a pattern of black and white squares to hold data. In an isotopically encoded object, the different isotopes of nickel could be the black and white squares. The entire probe could be a complex three-dimensional message written in the language of physics itself. The amount of information you could store this way is staggering, easily dwarfing every computer on Earth combined. A single chunk of this alien metal could contain the entire history, science, philosophy, and art of the civilization that created it. To read it, you'd need technology far beyond what we have now. but the message would be perfectly preserved for eons, protected from the harshness of space, waiting for a civilization advanced enough to scan it. This is, of course, deep into the realm of speculation, but a mysterious object like 3/ATLAS is forcing us to speculate. It has presented us with a set of facts that don't fit into our neat little boxes of how the universe is supposed to work. Whether it's the random debris from a cataclysmic cosmic explosion or a carefully crafted piece of alien technology, one thing is clear: it's a discovery that will be studied for decades. It's a fundamental challenge to our place in the cosmos. Are we the sole intelligence in this vast emptiness, or are we just the new kids on a very, very old block? The answer is still out there, but this visitor just might be the key to finding it. Humanity's fascination with the stars. Humanity has always been obsessed with the things that fall from the sky. For most of our history, we had no clue what stars, planets, and comets really were. They were mystical signs from the gods, terrifying omens of good or bad fortune, or the shimmering spirits of our ancestors looking down on us. And every now and then, the heavens would throw down stones. These rocks that fell from the sky, which we now call meteorites, were seen as incredibly powerful and sacred objects imbued with the magic of the cosmos. The thing is, our ancestors weren't wrong to be amazed by them. These rocks were truly special. They were made of a substance they could only describe as sky metal. Long before humans figured out the complex process of smelting iron from ore dug out of the ground, a discovery that required massive amounts of heat and kick-started the Iron Age, changing civilization forever, they were already working with iron they simply found. This iron came directly from meteorites, and meteoritic iron isn't like the stuff you find in the earth. It's a natural alloy of iron and nickel, often in a 10-to-1 or 20-to-1 ratio. The thing nobody tells you is that this touch of nickel makes the metal a game changer. It's harder, far more durable, and incredibly resistant to rust compared to the pure, soft iron that early blacksmiths could produce. To ancient people who had never seen anything like it, this was a miracle material, a gift from the gods themselves. Take, for example, the famous dagger of King Tutankhamun. This incredible artifact was buried with the boy king over 3,300 years ago and was discovered pristine in his tomb in 1922. The blade is exquisitely crafted, a testament to the skill of ancient artisans. But what's truly astonishing is that it shows almost no signs of rust. For decades, people were baffled. Then, in 2016, scientists using advanced scanning technology confirmed what many had suspected. The dagger was forged from a meteorite. Its high nickel content is what preserved it through the millennia. But the story gets even crazier. The Egyptians didn't just value it for its durability. Their texts describe this material using a term that translates to iron from the sky, meaning they knew it didn't come from the ground. They were knowingly working with an extraterrestrial alloy, a material they believed held divine power. You find similar stories woven throughout human history, all across the globe. For centuries, the Inuit people of Greenland relied on a massive iron meteorite they called the Cape York meteorite. It was their only source of metal. For generations, they would travel to this sacred rock and painstakingly chip off small pieces to hammer into tools and harpoon tips. It was their lifeline in one of the harshest environments on Earth. Ancient artifacts from the Hopewell culture in North America to remote monasteries in Tibet have been found to be crafted from this very same sky metal. There has always been an understanding, on a deep, almost instinctual level, that some materials are not of this world. Now let's slam the history book shut and jump to today, because we are, once again, staring at a piece of metal from the sky. But this time, it's not a small rock that landed on Earth, destined to become a king's dagger or a hunter's tool. It's a mountain-sized object flying through our solar system at an impossible speed, and its composition is far, far stranger than the simple iron-nickel alloy of our ancestors' wildest dreams. This brings us to the most critical question we might ever face. Is this all just a coincidence? Seriously, think about it. Is it a coincidence that our very first interstellar visitor, Oumuamua, had a bizarre shape and accelerated as if something were pushing it? Is it another coincidence that our third visitor, 3I/ATLAS, has a chemical makeup that defies natural explanation and is following a trajectory that seems statistically impossible? How many more cosmic anomalies do we need to encounter before we start taking the alternative possibilities seriously? In science, a coincidence is often just a clue you haven't figured out yet. The scientific process is slow and cautious, and for good reason. You have to rule out every possible natural explanation before you can make an extraordinary claim. But there's a massive risk in being too cautious. You might miss the single greatest discovery in human history because you were too afraid to even consider it, too worried about what your colleagues might think. For most of us, this all sounds like something out of a blockbuster movie. We live our daily lives worrying about jobs and bills and what to watch on TV, while these grand cosmic dramas unfold silently above our heads. But you need to think about what this really means. If 3I/ATLAS is an artifact, it implies that somewhere out there, another form of life became intelligent. They mastered science and engineering on a scale we can't even comprehend. They built machines capable of crossing the vast empty gulfs between stars. And they did it long, long ago. So long ago that their probe is only just now reaching us. Are they still out there? Are they watching us right now? Are we just a tiny point of interest on a galactic map they've been charting for eons? The thing is, we've gone from believing we were the center of the universe to understanding we live on a small rock orbiting an average star in a quiet backwater corner of a vast galaxy. The final step in that journey is realizing we might not even be the only ones asking these questions. So, is 3I/ATLAS a 1 in a trillion natural marvel, or is it undeniable proof that we share the universe with someone else? Let us know what you believe in the comments below. If you want to explore more cosmic mysteries, make sure to like this video and subscribe. Is our refusal to see the evidence right in front of us the biggest danger of all?